Hello guys, today I'm gonna show you one of the cool projects that I accomplished pretty recently, not too long time ago, maybe in previous year. So I just remembered and upgraded this project. This is a Sudoku solver, and let's give it a try first, and then I'll show you the code, and also I'll put the link to the GitHub repository in the account. Here I found some very difficult Sudoku. As you know, Sudoku is like puzzle game. You have to solve it like to make different numbers in the rows and in the columns, and also in these like 9 quadrants, like in the first one, second, like 3, 3, 3, and in these quadrants and rows, there should be unique numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, and also in rows and in vertical columns. So here is a can you solve the hardest ever Sudoku? Let's try this one. So gonna fill the same number like 3 and 7, and here we have 6 and 6 and 9, and here we have 2, yeah, here we have 7, and here we have 3, here we have 1, 4, 7 again, and 5, and in this one we have only 5. So here 1, 8, 9, here 5 again, and here we got 4, 1, okay, 6, 6, and 8. So let's check it again. That's 8, 3, 7, 6, 9, 2. And here is 5, 1, 4, 7, 5, 5. I'm doing this one. 7, 3, 6, 8, 1, 4. Okay, 5, 5, 1, 8, 9, 1, 8, 9. So here is little check mark like show progress. It will show like how it's like cracking our Sudoku. First, it will define how many combinations or permutations we have for each row. And then algorithm works like it's trying the permutation for one row, and then the next one, and if there is no possible options, it does step back and checks the next option, and trying like the same, like trying and trying and trying to go further and further and further until it reaches the top, the bottom row. Yeah. So when it's solved, it shows the results. So but now we check this show progress, and we will see how it's going on in progress. Let's try to solve it. Okay, looks like it's done in 1 second, 68.68. And let's check it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So all unique numbers here, and this row, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can stop the video and check everything. It should be correct. I'm just rechecking a couple of rows and columns also. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, everything looks fine. Let's check the code. So I'm gonna move this example. Okay, I'm gonna move my browser. Maybe there is a browser. I'm gonna move it to the third one, and here I can open the code. So here's the script. This is a Python script using tkinter for GUI, and here I defined some functions here. This is a check function. This function is checking if the current number is doesn't have any conflicts with the rest. I called it matrix, like this 9 by 9 table, like board. I called it matrix in this script, and this is this m, the numbers, and its coordinates. And we are checking if it doesn't have any conflicts in the row and in the column. And also here I define the quadrant, like 3 by 3, and checking this quadrant as well. So it's pretty simple. And we go further. Then this function, write matrix, it's actually writing the input from the user, and it allows keyboard movements. So I can use arrows on my keyboard to go up, down, left, right to enter the values easier. And here is also checking if it has conflicts. It shows in the red color, or it's an improper number or something like that. If everything is okay, it shows as a black color number. So here is a if we found any permutations or combinations, we kind of show we can show it how many of them for each row. So, and here this is a helping function. It's checking the row consistency. If the row doesn't have any conflicts and it fits well, so it returns true or false if it's something wrong. And this function is we are searching for a number of all possible permutations or combinations for each row. We go row by row through all our matrix, and here we just remove from our list of possible numbers all the numbers that I already defined in the row. So we take set of these numbers from 1 to 9 and subtract the set of the predefined row. So this way we kind of can move on easier and faster. So then this is a set p, like helping function. It's the function to try to set the one of the permutation in the row to make the further checking. The further checking will be happening in the next function. So this is a just show solution function, just to show it in the GUI. And this is the most interesting one. This is actually the algorithm of the searching. Here I define this list of a length of how many permutations for each row we have. And here is like a quick checking if for any of rows currently we don't have for some reason any combination, so it means there is no solution for this Sudoku puzzle, so it just returns false and shows the message that no solutions. So then we need, for working the algorithm, this list of indexes. For each row, I have to track the index where the algorithm actually stopped searching for the permutation for the current row. Because here, this is like a step counter. So I'm going row by row, checking the roll number 0 first, then number 1, and so on up to the roll number 8. So from 0 to 8. And here I'm starting with zeros 1. And if I found the fitting permutation for this list, I'm going further. I'm incrementing this I. And for some reason, I went through all the permutations from the next row and they all didn't fit. But it's not done yet, and I have to go step back. Here's my decrement of the step counter. It's if it's available, if it's possible, I can do a step back and try the next fitting permutation for the previous list and try to go further again. So this algorithm kind of trying to start from the beginning and go further, and if it getting out of permutation somewhere else, it goes step back and checking the next fitting one and trying to go further again. Here, for example, this is an interesting condition. If I is getting less than 0, so it means if we out of permutations and if we came to the row 0 and there is no any possible available permutation that fit, so it means we out of our options and there is no solution again. But okay, so this is like a no solution no solution option. And also, but if we found something false, we go further and further and further again. And finally, if we came to the last row and found the solution in for the last row, so it means all the matrix completed and there is no any conflicts and nothing wrong. It means we successfully ended this loop, this algorithm, and we show the solution for the user. Here is a little thing. This is a be-live like Boolean, and it means this is a checkbox is checked, show progress in live, so the user will see how the progress is going on. So this is actually it. Here's a little helping reset function. There is a, if you notice the little buttons like reset and clear, we can reset our matrix, kind of a return it to the state when the predefined numbers were entered by the user, or clean it. It means just remove everything, just make it clear. So, and further here, it's just GUI definition. It's pretty simple stuff. Just on the here, I'm just made a little bit tricky here thing just to make the quadrants looking a little bit different, like white and yellow colors, like I made it here. So for example, I made my matrix like looking like this one is yellow, white, yellow, just to make it easier and more convenient to enter the data. So this is it. I'll put this in my repository in GitHub and put the link in the description to the video. So feel free to use it, to have fun, and thanks for watching, and bye.